Today we are learning all there is to a queue data structure. There are three different types of queue: a regular queue, a double-ended queue, and a priority queue. In this video, we'll only go over the first two types of queue, a regular queue and a double-ended queue. If you guys are new to the channel, I make programming tutorials, and currently I'm doing a series on data structures. I hope these videos are helpful to you guys, and soon we'll be diving into bigger projects where we are going to be using some of these data structures. So what is a queue data structure? In the last video, we went over a stack data structure, which is a last in first out data structure. Queue, on the other hand, is a first in first out data structure. What that means is if the first element that is inserted inside the queue will be the first one that's out. You can think of it like when you stand in a line. First person that's on the line will be served first, and so on. It's like the saying, first come, first serve. So let's do an example of a queue. Let's say we have a car wash where cars are lining up to get their car wash. Queue would be a perfect data structure to simulate this. To define a queue, we have a queue interface that is part of Java util package. And let's call this is going to be of type string. And let's call this car wash queue. Now, since queue is an interface, we cannot directly instantiate it. What that means is we cannot say new queue. We can't do that. We need a concrete class to implement the queue, and in Java we have two classes that can implement it, a priority queue and a linked list. For this example, we're going to be using linked list. Now let's start building our car queue, and to add a car to our queue, we just have this add method. So let's say we have car 1. Let's say we have 5 cars in our queue. So let's do that. All right, let's print this queue out. Okay, so let's run this. All right, so we have our queue printed out. So the first item on our queue list would be car 1, and then last item would be car 5. We have this peek method in our queue, which basically tells us, what's the first element in our queue. So we can print that out. So the first element would be car 1. All right, so car 1 is the first element in our queue. So here's an illustration of how our car wash looks like. Whenever a new car comes in, it gets added to the rear of the queue and starts moving ahead whenever a new car comes in. And when we have to remove an element, we remove from the front of the queue. So let's do that. To remove an element from a queue, we have two methods. We have remove. So if I go to a car wash, we have remove, and we have pull. Now the difference between pull and remove is if the queue is empty, if we're going to use a remove method, and if the queue is empty, it's going to throw a null exception. And pull will just return null. So let's use null. And let's print out our queue again. Now we're going to have 4 cars in our queue. So after I run this. All right, there you go. So car 1 was removed from the queue, and we have 4 cars left over. So let's process this queue. And to do that, we can just use a while loop. And we can say while our car wash queue is not empty, keep running this, keep emptying out the queue. So let's do that. Okay, so we can see how our queue is processing. So first we had 4 cars, and then we start running, now our queue is running. So we are removing the top element from our queue every time. So the car 2 got removed, then from here, car 3 got removed, 4, and then 5. Now, if this was a stack, it would work the opposite way. And the way it would work is it would start removing car 5 first, and then it's going to go up to 4, 3, 2, and then 1. Because stack is a last in first out data structure. Another type of queue that I want to go over is a double-ended queue. The difference between this type of queue and a regular queue is that in double-ended queue, we can remove or add from both ends of the queue. It pretty much provides a functionality of both stack and a queue in a single data structure. So let's do an example of this. We'll do an example of a palindrome using DQ. For those who don't know what a palindrome is, it's a word or a phrase that reads the same backward and forward. For example, dad is a palindrome. If we were to read dad forward or backward, it would be the same. And this is also a very popular interview question as well. So DQ is an interface just like a queue. And let's make this a character, DQ. And let's call this palindrome. And just like a queue, it's an interface. So we need to provide a concrete class that implements this DQ interface. And in Java, we have 2 classes, linked list and an array DQ. So let's use array DQ as it is more performant than a linked list. So first, let's define our string palindrome. And let's call the first one dad. And let's start building this palindrome DQ out. So to do that, we can do it actually in one line. So the first step we're going to do is convert that string palindrome into a character array. And then, sorry, a character list. So let's do that. So we're going to call chars. This will convert it to an int stream. And we can start mapping this to an object. So we can cast our ints to a character. And then from here, we can say to list. All right, so here we added all of our characters to this palindrome DQ. Now let's run this. So we can say while palindrome DQ, is not empty, start running this. So here we're going to see, okay, if now you can see the methods that we have access to in palindrome DQ, we have access to the first and the last. So we can take a look at peak first and peak last. Same thing, we can also add first and add last, and same thing, we can pull from last and first as well. We have access to both ends of the queue. So here, let's check the first and the last, and we can say, you know what? If the first and the last characters don't equal each other, that means it's not a palindrome. And exit out of the loop so we can break the loop. Otherwise, start popping off. So we can say palindrome pop the last and, sorry, pull the last and also the first. All right, let's run this and test this out. Before I run it, let me just clear this up a little bit. So that should be a palindrome. All right, so we did not get it. And let's say hello. Now, hello, we know it's not going to be a palindrome. Why? Because H is not on the first one and the last one. So we should see not palindrome. All right, not a palindrome. Let's do one more. So madam is another palindrome. All right, we did not get it. Let's do one more. Let's do poop. And let's do some random characters. Now, this is not going to be a palindrome. All right, so our logic is working. Another use case of a DQ can be implementing a browser history. For example, when we need to go back or forward, we can use a DQ to keep track of the URLs we visited. To recap, we went over a queue data structure. It is a first in, first out data structure. When we add an element to a queue, we add from the rear end of the queue, which is called enqueue. And when we need to remove an element from a queue, we remove from the front end, which is called a DQ. We also discussed another type of queue, which is known as a double-ended queue. It means what the word itself says, where we can remove or add from both ends of the queue. Hopefully this video was helpful to you guys, and if these styles of videos are helpful, please do subscribe to the channel. Take care.